Hi, this is Janakreddy Dubaka. Neet Physics Quick Revision, that is Formula Revision. And this is the lecture from Center of Mass, part 3. See here, motion of center of mass. Here, velocity of center of mass, acceleration of center of mass, and the momentum of center of mass. Sir, velocity of center of mass, VCM is equal to m1 v1 bar plus m2 v2 bar, so on, m1 mn vn bar by m1 plus m2 plus mn. Like that, acceleration of center of mass m1 a1 bar plus m2 a2 bar plus so on mn an bar by m1 plus m2 plus mn. Like that. See here, this is nothing but total momentum of the system, and this is total mass. Therefore, total momentum of the system is equal to total mass into velocity of center of mass. Here also m1 a1, m2 a2, and so on mn an, that is f external. This we can write down f external. F external bar is equal to total mass into acceleration of center of mass. See, here is one numerical. These are the two bodies A and B having mass m. This is 30 degrees and this one is 60 degrees, placed on two inclined planes. When these two bodies are released, find the magnitude of acceleration of center of mass of two blocks. See here, this angle is 60 degrees, this is 30, therefore this one is nothing but 90. Therefore, this I am taking x-axis and this I am taking y-axis. And it is moving with an acceleration g sine 30 and it is moving downwards g sine 60. Therefore, here a1 bar, that is equal to g sine 30. Sine 30, this is y-axis j cap. Sine 30 means 1 by 2, g by 2 j cap. A2 bar is equal to g sine 60 I cap. X-axis means I cap. This sine 60 root 3 by 2. Therefore, root 3 g by 2 I cap. Then acceleration of center of mass ACM bar is equal to m1 a1 bar plus m2 a2 bar by m1 plus m2. Here both the mass having same mass m. A1 bar is g by 2 j cap. A2 bar is m into root 3 by 2 I cap by total mass m plus m 2m. Therefore, here this m gets cancelled. Therefore, here ACM bar is equal to, this becomes g by 4 j cap root 3g by 4 I cap. This is the acceleration. But we have to find out magnitude. ACM bar is equal to g by 4 into j cap plus root 3 I cap. Therefore, here modulus of ACM bar is equal to g by 4 into square root of 1 square plus root 3 square 3. Therefore, 3 plus 1 4, 4 root 2. Therefore, 2g by 4, that becomes g by 2. This is acceleration. See here, this is Atwood vision. Here m1 and this is m2. m2 greater than m1. Then acceleration of center of mass of the system. See here m2 greater than m1. Therefore, it moves downwards with an acceleration a. It moves an acceleration a upwards. See, this acceleration a is equal to m2 minus m1 by m1 plus m2 into g. Here this acceleration considers positive. Therefore, here a1 is equal to plus a and a2 is equal to minus a. Therefore, here acceleration of center of mass, this becomes m1 a1 plus m2 a2 by m1 plus m2. See here m1 a1 means plus a. Okay. Here a1 minus a plus m2 into m2 is downwards. M2, sorry, downwards I am taking positive, upwards as negative. Therefore, this is 1, this one is 2. Therefore, A1 is equal to minus A, A2 is equal to plus A. So, minus A plus A by M1 plus M2. This becomes acceleration of center of mass, A common, this becomes M2 minus M1 into A by M1 plus M2. But A is equal to M2 minus M1. Therefore, acceleration of center of mass M2 minus M1 by M1 plus M2 into A means M2 minus M1 by M1 plus M2 into G. Therefore, finally, acceleration of center of mass M2 minus M1 by M1 plus M2 whole square into G. This is acceleration of center of mass of the system. See here another problem. See here, two bodies of mass 6 kg and 4 kg masses have their velocities 5 I cap minus 2 j cap and 10 I cap minus 2 j cap plus 5 k. Then velocity of center of mass. Direct formula substitution. See, velocity of center of mass VC bar is equal to M1 V1 bar plus M2 V2 bar by M1 plus M2. M1 is given as 6. Here V1 bar is 5 I cap minus 2 j cap plus 10 k cap plus M2 is 4. Velocity 10 I cap minus 2 j cap plus 5 k cap by total mass 6 plus 4 10. Therefore, here after simplification we can get the final answer. VCM bar is equal to 7 I cap minus 2 j cap plus 8 k cap. Next, see here another concept, displacement of center of mass. See here, this is the position vector of center of mass M1 R1 bar, M2 R2 bar and so on Mn Rn bar by M1 plus M2 so on Mn. If delta R1 bar, delta R2 bar and so on delta Rn bar are the displacement vectors of the particles of the system, then displacement vector of center of mass, that is delta RCM bar is equal to M1 delta R1 bar plus M2 delta R2 bar so on Mn delta Rn bar by M1 plus M2 so on Mn. This is the formula for displacement of center of mass. See here, see acceleration of center of mass is equal to F external by total mass. If F external is equal to 0 means there is no external force acting on the system. When F external is equal to 0, acceleration of center of mass 0. Acceleration of center of mass 0 means velocity of center of mass is constant. Velocity of center of mass is constant. See here, if no external forces are acting on a system, if the system is initially at rest, the velocity of center of mass of the system will be 0. Means velocity of center of mass 0 means displacement of center of mass will be 0. If there is no external forces acting on the system, if the center of mass of the system initially at rest, therefore velocity of, is the system is at rest, velocity of center of mass 0. Velocity of center of mass 0 means displacement of center of mass is 0. See, so by that concept, we can apply that concept into this problem. See here, two blocks of masses 10 kg, 20 kg placed on x-axis. The first mass is moved to the x-axis by distance of 2 cm. By what distance should the second mass be moved to keep the position of center of mass unchanged? See here, the position of center of mass unchanged means displacement of center of mass is 0. That is, here I am taking x-axis, therefore delta xcm. See, delta xcm is equal to m1 delta x1 plus m2 delta x2 by m1 plus m2. Here position of the center of mass does not changes means its displacement of center of mass 0. This is 0. M1 is given as 10 kg and it is the first mass is moved on the x-axis by distance 2 cm. M2 is 20 kg we have to find out delta x2 by total mass 10 plus 20 30. See, by cross multiplying, this is 0. So 0 is equal to 20 plus 20 delta x2. Therefore 20 delta x2 is equal to minus 20. Therefore delta x2 is equal to minus 20 by 20. Therefore delta x2 is equal to minus 1 centimeter. Means here the position of the center of mass does not changes. Means the first body, if move, it is towards right, the second body should be moved towards left. Otherwise, if the first body should move towards left, the second body should be moved towards right. Another problem based on this same concept. See, two blocks of masses 10 kg and 30 kg are placed along vertical line. The first block is raised to a height 7 centimeter. By what distance should the second mass be moved to raise the center of mass by 1 centimeter? Here the bodies are taken along y axis. Therefore, I am taking delta ycm. So here delta ycm is equal to m1 delta y1 plus m2 delta y2 by m1 plus m2. So here raise the center of mass by 1 centimeter. Therefore, displacement of center of mass is given as 1 centimeter. Mass m1 is 10 kg. It is the first mass raised to a height 7 and m2 is 30. We have to find out the displacement of second body and total mass 10 plus 30 40. See here, therefore 40 is equal to 10 plus 7 70 and this becomes 30 delta y2. 30 delta y2. Therefore, 30 delta y2 is equal to 40 minus 70 minus 30. Therefore, delta y2 is equal to minus 1 centimeter. So, here minus 1 centimeter means first body is raised upwards. Therefore, to change it does not change by changing of the center of mass by 1 centimeter, second body should be moved by downwards. That is indicates a minus sign. Therefore, with this, we completed total formulas that is very useful for Neet. We completed lecture 1, lecture 2, and this is lecture 3. Then we can move to next chapter, that is collision. Thank you.